The lesson outcome for this video is I can graph linear equations, and this is the work we're going to do for graphing in standard form. So first thing I want to do is I want to remind you what standard form is. I'm going to move those out of the way for a second. Alright, so standard form is written as ax plus by equals c. And the easiest way to graph standard form is by using something that I like to call the teeny tiny table. And I'm going to show you that on the next screen. But before I do, I'm going to talk about two very important terms that we need to know in order to use the teeny tiny table. And those are our y-intercept and our x-intercept. Now we've talked about y-intercepts already because we've talked in slope-intercept form about how we always plot the y-intercept first and then we move using our slope. Just a reminder what I'm talking about here, y equals mx plus b is our slope-intercept form, and that lowercase b here represented our y-intercept. So once we knew that number, let's say it was 5, we would go on the y-axis to 5 and we'd plot a point there. That is called a y-intercept. So let's say I told you that your y-intercept is at 5, like I just talked about. So if I had a point right here at 5 for my y-intercept, let's think about what that is as a point, because that's going to be really important here. What is that as a point, x and y? Well, here's our x-axis. If I start at the origin, how much do I move left or right to get to this point right here? Well, the answer is I don't move left or right at all. So that would be 0. So here's a 0 for x. And after I move 0 left or right, then I move up 5 to that point. So this y-intercept here is 0, 5. What if my what if my y-intercept was right here? What would that point be? What if I had a y-intercept down here? Well, that would be once again 0, comma, and then it would be -7. So if I had a point right here, okay, that would be 0, -7. No matter where I am on this y-axis, I always have 0 for my x-coordinate. And then my y-coordinate is that point at which I'm at. So an x-intercept, I'm sorry, I said it again, a y-intercept has an x value of 0. A y-intercept has an x value of 0. So then what happens when we're talking about an x-intercept? Well, let's say our x-intercept was at 3. Let's say we knew there was a point right here at 3 on the x-axis. How do we write that as a point? Well, this time, from the origin, how do we move right or left to get to this point? Well, we move right 3. So our x-coordinate is 3. And then how much have we moved up or down? Well, that would be 0. So our x-intercept is 3, 0. What if our x-intercept was over here? Let's say right at this location. Again, it's an x-intercept, or a point on the x-axis because it's on, because it's on the x-axis. So where is this point? Well, from the origin I moved left 8, so -8, and up or down 0. So -8, 0. So just like we noticed that a y-intercept has an x-coordinate of 0, a x-intercept has a y-coordinate of 0. And that's always true for x and y-intercepts. Now let's see why this will help us graphing linear equations in standard form. Okay, so here's an example of an equation in standard form. Again, like I showed on the previous screen, it's like ax plus by equals c. So unlike slope-intercept form, when let's say we had y equals 3x plus 5, we were able to use the 5 to plot a point and we were able to use the 3 to plot a point. We do not do that in standard form. We do not just grab the 3, the 2, or the 12 and plot them. Okay? What we're going to do instead is we are going to use something I like to call the teeny tiny table to find our x and y intercepts. So look at this table here. It's just like a table of values like we have already graphed with, but I have a couple of specific values in my table already. And that is, I have a 0 in here for x, and I have a 0 in here for y. All right, now why do I have that? Well, 0 is a really handy number to use. And if we put 0 in for x, what did we say on the previous screen we're able to find? Well, 0 in for x, if you think about a point, a 0 in for x helps us find our y-intercept. And then what if we put in a 0 for y? Like this, a 0 in for y. What are we going to be able to find? We're going to be able to find our x-intercept. Well, if we can plot a point on the x-axis and we can plot a point on the y-axis, we can connect those 2 points with a line, and then we have graphed our function. And again, why is 0 so handy? Well, let's find out. We're going to use this space right here to show our work to find these 2 values. So I'm going to start by writing my function 3x plus 2y equals 12. And I'm going to start by putting a 0 in for x. All right? So I'm going to rewrite this 3 times 0. I'm going to put a 0 in for x plus 2y equals 12. Now, what is 3 times 0? Well, 3 times 0 is 0. So that's why this is so handy, because when I do this work right here, 3 times 0, it becomes 0. So I can just write 0 plus 2y equals 12. Now, do I need 0 plus here to solve this equation for y? Nope, I don't. So I can actually just ignore that 0 part and just solve positive 2y equals 12. Well, to solve that for y, all we need to do is divide both sides by positive 2 of our equation, and we get y equals 6. So y equals 6 is our y-intercept. 0 put in for x. Again, we're just using like a table. Put a number in for x and solve for the other variable, which is y, and we have found 0, 6 as one of our points. Now, when I had you graphing with a table, I actually had you write that point off to the side over here, and I wish I would have done that on this teeny tiny table, but I'll write it over here. Notice that 0, 6 is this right here. When I put a 0 in for x, I get 6 for y. So there's one point. Now we can plot that point on our coordinate plane. 0, okay, from the origin, we're moving 0 left or right, and we're going up to 6 on the y-axis. Notice y is 6. So y is 6. We're going to put a point right there. Now we're going to do the same thing to find our x-intercept. All right, we're going to do 3x plus 2y equals 12. We're going to put a 0 in this time for y. So I'm going to write 3x plus 2 times our y value, we're putting a 0 in, equals 12. So we have 3x plus what? Well, 2 times 0 is 0. So 3x plus 0 equals 12. Again, does this plus 0 mean anything? No, it means nothing there, because adding nothing means you're not doing anything. So we can cross off that adding 0, and we're able now to divide by 3 on both sides of the equal sign, and we get x equals 4. 12 divided by 3 is 4. So I can put a 4 right here, because I found out that x equals 4 when our y value was 0. So now we have another point over here, 4 comma 0. Okay, from right here, when you insert x equals 4, you get an output of 0 for y. Now we did do it the other way around when we found the values, but we can still think of it as input-output. So 4, 0 is going to be plotted, well, again, from the origin, we're going to go 4 to the right on the x-axis and up or down 0. So it's going to be right here. Okay, x is 4. So on the x-axis, 4. If I know both of those points are on this line, I can now draw the line through those 2 points. Again, extend that all the way through and include arrows to show that it goes on infinitely. All right, let's try just one more, and this one will be a little quicker, but we also have to make sure we're careful with the fact that this one has subtraction in there. All right, so we're going to put a 0 in for x to find our y-intercept. We're going to put a 0 in for x to 0 in for y to find our x-intercept. All right, so here's our function. 4x minus 5y equals 40. I'm going to put a 0 in for x, so 4 times 0 minus 5y equals 40. What is 4 times 0? Well, 4 times 0 is 0. Now be really careful here. The 4 times 0 becomes 0. Okay, we still have 0 minus 5y equals 40. If I want to get rid of that 0, like I had on the previous example, I don't need this 0 anymore. I can get rid of the 0, but I cannot get rid of the sign that's in front of 5y, which is a minus sign. The 5y is negative. So if we're going to solve this for y right now, what do? Well, we divide both sides by negative 5. So if you had crossed that negative sign or minus sign out, you would get the wrong answer here. We need to divide by negative 5. So y equals 40 divided by negative 5, which is negative 8. So our y value, when x is 0, is negative 8. Again, that means that's our y-intercept. So on the y-axis, we're going to plot negative 8. So negative 8 is here on the y-axis. All right, now we're going to put a 0 in for y. So 4x minus 5 times the 0 for y, it's a 0, okay, equals 40. Well, we have 4x minus 5 times 0. Well, 5 times 0 is 0. Equals 40. The minus 0 doesn't matter. Now at this point we can cross off not only the 0 but the minus sign, because the minus goes with the 0. So we're taking away nothing. So in this case we don't need any of that anymore. So now we have 4x equals 40. We can divide this side by 4 and this side by 4. And we get x equals 10. So 10 is our x-intercept. When y is 0, our x-intercept is 10. So that is over here at 10 on the x-axis. And we can now draw our line through those points.